Jonathan Klain. I am BioRAFT's Director of Risk Management and Safety Education. I am an EHS professional of over 30 years. I was like 30 years, 3 decades, and I almost said 30 decades. That would be pretty awesome, I think, and pretty awful, I'm pretty sure as well. I don't want to go that long in the career. And used to work in academia, used to be a consultant, working in a ton of industries, having lots of fun and craziness. And you know what, and these days, just really working on research on the softer side of things. So that's my intro, and that's enough from me. Let's do intros of our panelists here. And so I've got the slide up showing the 3 of you, so it helps. I'll just go straight across. So Ashley, you're up first on this, please.
So I'm Ashley Augsburger. I have a PhD in analytical chemistry, and I am the chemical hygiene officer at Corteva Agrisciences in Johnston, Iowa.
Very cool. Thank you, Ashley. Chris.
Chris Kolodziej. I am the chemical hygiene officer at UCLA, and background is PhD in chemistry, also from UCLA.
Nice. Thanks, Chris. And Jodi.
Yeah, so I'm Jodi Ogilvie. I'm the chemical hygiene officer for the University of Minnesota system, and I am the interim research safety manager. My background is in organic chemistry. I got my PhD from the University of Vermont, and I did my postdoc here at the University of Minnesota before going into safety.
Very cool. And I've been to the University of Vermont, actually. Yes. Yeah. Oh, it's absolute gorgeous campus. Grew up in Mass, worked in Maine, and just absolutely loved it there. All right, I need to bring up the question. So again, for all of you wonderful attendees, this is the reason we're doing this. There's about 225 right now, so this is fantastic. If you just joined us, you are certainly right on time. And because we're going to jump right into some wonderful questions for our panelists, right? So let's start with really, let's talk right away about resources. I think this is a great thing that people always want to know. Do you have recommendations on resources that folks can use? What are the ones that you really go to? That you would recommend for those of us like myself? I'm not a chemical hygiene officer. I have 0 degrees in chemistry, maybe negative degrees in chemistry, if that's even possible. I've forgotten more than I've learned. How's that, right? So, and yeah, anything that you've got for recommendations, and I'll start with Chris.
Sure. So, I mean, in terms of, chemical or lab safety, you kind of always start with prudent practices, right? That's kind of the big go-to reference for that. If you're diving a little more specific into a particular chemical or chemical mixture that someone's coming to you with, there's resources like PubChem or Cameo Chemicals are pretty good for those things. And then one that I've recently been turned on to is something from Elsevier called Novel, which can give you electronic access to some of their resources. So you can get like Rethrix, which is kind of the Bible of reactive chemicals. So you can have that on your cell phone, which is nice.
Cool. And it's interesting seeing your fellow panelists, Jodi and Ashley, both nodding their heads. Yep, that's something. And I'm like, Rethrix, I've never heard of that before. So this is awesome. The one thing I will mention in case any of the attendees are interested, so Prudent Practices, which has been around for quite some time and is a very useful document, and I do not claim to have read very much of it at all, is available online on the National Academy of Sciences website for a free download. You have to register with them, but I've been registered with them for I don't know how many years, and I barely get any emails ever, but you can go to their site, you can find Prudent Practices, you can register and then download the entire document, which is really nice. So great. Yeah. And it looks like someone might be asking for things in writing. We'll try to include that. What we've done, oh, there it is. Jessica has actually mentioned, has given the link. Thank you very much. So this is why it's a community. So we love it when our attendees can help as well. And we'll try to get a good list of these things. I'm going to go to Jodi and then Ashley on this as well. And we'll try to get a list in the Q&A or in the chat or something like that. And we're starting to develop a habit of getting some of this listed afterwards and then posting the document on the webinar page. So Jodi, what would you like to add to this on resources, please?
So I guess for kind of some of the solid resources that you can go and search yourself, I'm just going to echo what Chris said. PubChem also has lab chemical safety sheets. So they're kind of more safety focused summaries for some of the common chemicals. The other resources that I have, and I will say these are more kind of community resources, are places like if your institution has a membership to say SHEMA and you have the ability to talk to the lab safety community of practice, or DCHAS, the Division of Chemical Health and Safety through the American Chemical Society. The American Chemical Society website in general has a lot of really amazing resources, amazing risk analysis resources, things like that. But that kind of gives you a link to a community that you can go and ask a question to. Sometimes it's good to talk to someone who may have some of those a little bit more experience, so you can have a dynamic conversation. Another one was I see a lot of conversations in the hazardous waste forum as well. So I know that that's more focused on hazardous waste, but they do definitely talk about chemical safety as well. And so beyond maybe some resources at your institution, which we can certainly get into later, like the researchers, these are kind of some outside resources that I rely on quite a bit. And I'll try to link some in the chat too while Ashley's talking.
This is great. And I'm watching the chat as well. And Jennifer, I'm with you. I thought of novel like, new or a book, not with the silent K. So thank you, Chris, for posting that. So great to have such a wonderful community around this. This is why we do this. So Ashley, what else would you like to add to this, please?
I don't really have any new resources. I am on Novel all the time trying to get resources. And I am on Cameo all the time trying to, for like chemical compatibilities, we're doing a lot of hazardous waste characterizations right now. So I'm trying to see like what can go together. And Cameo gives you a great table of what is compatible and what's not compatible if you put in certain chemicals, and what can happen if you put two chemicals together that should not be together.
And that's always been mine. What can happen, right? I'm no chemist, so what can happen with this? I mean, I knew enough to get through the CIH and all of that, but having a person, sort of like you all that I worked with was wonderful, because she could manage all of this sort of stuff. She was a former researcher, as you all are. Great. And also, several of you, I think, mentioned the various forums, discussion forums. I, in my career, have found those incredibly helpful, because I would just watch conversations and make notes of things for things that I might run into in the future, or I knew, hey, here's a wonderful community that I can reach out to as well, which is just really great. We'll try to get as much of that into the chat. And then we'll try to take the chat, look at what we've got, see if we need to add anything, and maybe make a list. So thank you all. I'm going to take us in the direction from chemistry to people, because we would not be doing this were it not for people, of course. And so how do you end up talking with the researchers and the scientists? Do you find it that you do certain things? Do you find it helpful to approach them early on? Also they're working from a different perspective. So any perspective taking that you do that you have found helpful help us out with that. And I'm going to keep mixing up the order here, mainly to keep my panelists on their toes, of course, right? So I'll go to Ashley first.
I talk to researchers all of the time. That's how you're going to know what they're doing and what they're using and how they're going to use it. And at Corteva, we have it's a lab hazard assessment. So anytime we have a new process starting or you've changed a process, you have to go through a hazard assessment again, which forces you to reach out to me. And I come to your lab and I ask you a whole bunch of different questions, like what are you using? Why are you using this chemical? Are there safer options? Often, because of conversations with other researchers, you already know of safer options. Or the researchers can point out the hazards of their processes before I even start. So it's really great to have an open conversation, and transparency is really important.
Great, thank you. All right, I'm gonna, just for ease of myself, go backwards across here. So Jodi, on my screen, you're in the middle.
Yeah, so I'll say that I talk to researchers all the time, and that is probably one of the biggest resources that I have, because they are the experts in what they do, right? They know everything about, theoretically, the research that they're doing. And so they can kind of tell you a little bit about, you know, the reaction that they may want to do. And what I'll also say too is I'll kind of stay in the realm of answering my questions in the perspective of someone who's not comfortable with chemistry. So if you're not comfortable with chemistry, the researchers are still an amazing resource, because they can tell you exactly what the reactions are. And if kind of the chemical information is overwhelming, you can get them to talk about the hazards of their reactions, like Ashley kind of mentioned. So does this reaction involve heat? You know, do you do it at high temperature, low temperature, high pressure, low pressure, things like that. Going to visit their space is incredibly beneficial, because you can see what they're working with. You know, do they have a new facility with state-of-the-art everything and everyone's working in a fume hood? Or is it an old facility? Or are 3 researchers sharing one fume hood, and maybe one person's trying to do a high hazard reaction in that fume hood? You know, how do you mitigate that? And so I would say that starting with the researchers, get them talking about their research, because that's what they love. Get them to kind of open up about that process, because they may say things to you that check boxes of, you know, where you might have a safety concern, like, oh yes, this is a high pressure system. Wait, what do you mean a high pressure system? Tell me how it works, kind of thing. And so even if the chemical identities themselves are overwhelming, getting them talking about the process and kind of looking at their facilities to see the controls that they have in place, if they have any, asking them for SOPs, things like that. We unfortunately don't have, you know, this system where people have to tell us what chemical reactions they're doing and we sign off on that. So that's amazing, Ashley. But, you know, we can kind of, we partner with different colleges to kind of get that information. And so our information comes from the fact that we know the researchers, we know their research, and they know that they can come to us. I guess I'll stop there.
No, that's good. No, this is great. Thanks. Chris, what else
Yeah.
would you like to add?
I mean, just, you know, kind of to amplify what Ashley and Jodi have already said, you know, it's absolutely invaluable, you know, talking to researchers, and, you know, really it goes, you know, from, you know, the beginning through the end of the process, right? I mean, you know, it's not that, you know, we're gonna, you know, talk to them a little bit about what they're doing, and then, you know, hit them with this magical solution to all their problems, right? You know, what Jodi was saying about, you know, the researchers being the experts in their process is absolutely true, right? You know, they know what sorts of controls are going to work. You know, they know what sorts of controls just won't work for what they're doing. And, you know, if you're not having that, you know, back and forth conversation, you know, you're never going to get to that point where, you know, you've got a set of controls that meets your, you know, institutional safety needs, but that also, you know, lets them get their work done.
Yeah, this is great. Thanks so much. So sort of staying on this topic of talking with others, because of course, that's what it's, like we said, that's what it's all about. How do we interact? How do we engage? How do we help them help themselves, etc.? So, so those of us like myself, so I not only don't have a PhD in chemistry, I don't have any degree in chemistry, like I said. So I always struggled with how do I approach for some of the advanced concepts or cutting edge. For me, I was always more than happy to say, look, this is way above me. I don't understand this. I felt very secure in confessing my ignorance of the topic and saying, just, explain to me as best you can, and I'll try to help out there. And they always took that well. But what would be, from your perspectives, what would be your advice? And I'll start with Jodi this
time. Sorry, I was reading the chat. I was reading the chat
I know.
specifically.
It's hard. There's the chat. There's the
I
Q&A.
And I'm because I try to answer things in the chat. So could you rephrase the question or repeat your question?
Let me go to Chris, and then you'll pick up on it again, right? So Chris, again, how for you all, you're CHOs, you have PhDs. So what is for those of us without that knowledge, how do we approach someone on some of these more advanced concepts or cutting edge research? Do you have any tips on that?
Yeah, I mean, honestly, you just approach them with curiosity, and I don't think it's all that different. PhD versus not PhD, right? I mean, I am an expert in the research that one lab here on campus does. I am not an expert in the research that virtually all of the rest of the labs do, and so I'm just as reliant, despite the PhD. I'm just as reliant on learning from the researchers about what they're doing, and where some of those risks might be.
Cool, great answer. Ashley, what about you? And then we'll go back to Jodi, of course.
I always have the researcher talk about their research. They love to talk about their research, and you can always ask questions. And I start with basic questions as well. Like, does this reaction produce heat? What are the vapors that could be produced? Do you need to use it in a fume hood? Can you do this process in a fume hood? Yeah, just transparency, and then asking them a lot of questions, even if they're basic.
Cool. Perfect.
And I think
Jodi.
I think I partially answered this maybe with the last question, but again, like both Chris and Ashley have said, get them talking about their research, and knowing that maybe you may need time to process that information. So what I'll do sometimes is I'll ask them for their procedure, the procedure that they're following. I'll ask them for I'll ask them about their information, about their reaction or about their research, and then I'll ask them for the procedure, maybe the journal article, something like that, so I could take it back and process that information. One of the traps that I think some people can fall into is that they feel like they need to give an answer right away, and so you kind of keep asking questions until you understand, or at least drill down to a level that you can understand. So again, falling back on that, is it high temperature, high pressure, what the different kind of hazard ranges are, and then looking at what they have, what experience they have too. So getting a feel for, is this a biology lab that never does air sensitive chemistry and all of a sudden they want to use TB to lithium, or, is this, so just kind of seeing what their level of comfort is and kind of what their range is, what the realm is, and then what they want to do, and then what you need to do to kind of get them to that place, I guess.
Yeah. I can really understand how researchers would all of a sudden say, oh my goodness, look at this chemical I wasn't thinking of for my research. I think this can help me with my research. And I mean, that's what researchers do. I'm in a PhD program as well. I get excited about this stuff, and then I have to think, oh my goodness, how am I going to get this information? Well, mine doesn't involve chemicals, right? Mine's social science. So, but easily I can understand that. And all of a sudden they're trying to play way above their level, to use a sports metaphor, and they might get mopped up on the court. Now I'm really mixing metaphors here. Right. But, whatever works. So, I think, there's two directions I want to take us in. One, of course, is to talk about our approaches or your approaches on the more technical side. So why don't we go in that direction first, because I'm sure there's a lot of interest there based on the Q&A. But then after that, we'll probably return to this, we're all human. We all have really widely varying risk perceptions. And so sometimes people are incredibly risk tolerant on something that they should be a little more risk averse. So I think we'll come back to that. So what about any more simplified approaches, maybe hazard classes? Is it helpful to think in those terms and then move to the chemicals? Or, is it really as complex as I, of course, think it must be with chemistry? So whatever direction you want to go there. And I don't know, I'll try Jodi again first.
Yeah, so I will say that one of the ways that I like to classify things, I do like to talk in hazard classes. So when we talk to different researchers, or even when I talk to other safety professionals who may not be as comfortable with chemistry, is we kind of look at hazard classes first. So how to safely work with flammables, how to safely work with corrosive material, how to safely work with oxidizers, things like that. And then you go up the spectrum, you go to reactives, you go to things that may need special controls like high pressure, high temperature reactions. Because in general, the way that I like to try to simplify it for people, and even for my researchers, is if you control to the highest possible hazard that you can, in general, you'll kind of take care of a lot of the potential concerns. So you don't need to look at a specific chemical and say, okay, you need to use exactly these gloves, or you need to do exactly this thing for this one particular reaction. You can look at a class of reactions and say, all right, if you work in a fume hood, if if it's a new reaction to you, start off at small scale. If you use this type of glove, it'll generally cover all of the, it's generally compatible with all of the things you might be working with. If you use a lab coat, that kind of thing, then you can take care of the need to really do it for every specific reaction, because I think that gets overwhelming for you and it's overwhelming for the researchers. So I like to look at hazard classes first. Now, that being said, sometimes obviously in chemistry, they get mixed, right? And so we were talking beforehand and Chris brought up the fact that, storage is very different than reactivity, right? And so you might want to mix two incompatible chemicals. And then I kind of look at, okay, what type of reaction is that? Is that exothermic? How do you control that type of thing? So
great.
I start with that.
Yeah, cool, wonderful. And Ashley, what from your perspective, what would you add?
Along the same line as Jodi, so we often work with chemicals that are brand new. Like we make them, and so we don't really know their hazards or any of their characteristics. So we look at what chemical is similar and then go off on that. So again, hazard classes and just trying to find similarities, and you don't have to go, like Jodi said, directly to that one specific control if you can control for the bigger picture.
Great. And Chris, what else would you like to add to this?
Not a lot. I mean, the chemical space is, as you alluded to very early on, incredibly complex, and well beyond the capacity of any person to have complete understanding of. So no matter what, you're going to be breaking things down into categories, and when you're talking about chemical safety, it's going to be hazard classes. That'll be the most useful way to kind of bin different materials.
Awesome, great.
And I'd like to add really quickly is that
Sure.
if you're not comfortable with chemicals, if you're not a person who can look at a chemical inventory and immediately know, if you look at the safety data sheet, the chemical classes are right there for you. And so that's kind of an easy way. You may not know based on the name of a chemical what type of hazard that would be, but if you look at the safety data sheet, if you look at the hazard information, it's right there, or in PubChem or something like that. And then you can see what it's compatible with and what it's not compatible with. So it's by doing it, in classes, sometimes people's chemical inventories can state the chemical hazard classes like right on them. So that kind of makes it easy if you're not, if the naming schemes overwhelm you, I guess.
Yeah, the nomenclature always overwhelmed me, right? Ein, ein, and the like, right? I think I figured that one out after a while. But then the other stuff, right? Hypochlorite, wait a minute, I know I'm supposed to remember this, right? So I always relied on, if you have an inventory and it's systematized, where the system will allow you to very quickly click on it and find all sorts of hazard info. To me, that was always very helpful. So Patrick had a comment in the chat that he liked the overall big picture hazard assessment, et cetera. And so I want to take us towards that and really talk about risk, because not only is it something that I enjoy talking about and I find it more useful, right, is what are actually the risks of it, but I think it's a good opening. So when it comes to this, how do you have the conversations, especially if their perceptions seem obviously to you off a bit, too far in one direction or another, or you're just not sure what they're going to be doing during their experiment? So how do you talk people maybe away from the cliff edge, or the opposite, they're not concerned enough? Let's just start with that one, and I won't double barrel or triple barrel this with adding on more questions. And I'll start with Chris.
Sure. So, if we're talking about, risk perceptions being off, first thing I think to start with is, try and get a sense of why you have a different risk perception than they do, right? Is it a question where they just aren't aware that a particular material is hazardous? That's, an easy one to solve, but certainly worth checking out. Is it a case where they're uncomfortable with all chemicals? If their risk perception is higher than yours. So trying to find out the source can definitely start you down the road of how you might want to address this, right? So if it's a lack of experience working with a material, maybe you can help them find someone who has run that reaction or run that procedure before, and they can kind of help walk them through it.
Cool, great, thank you very much. Ashley, what would you like to add to this? What does it take to talk to the scientists where you are? And you used to also be in academia as well, so you kind of have both pictures. I'd be curious about any differences there too.
Not too many differences between industry and academia. I find more differences in the type of lab you're in, biology, or even just in chemistry, analytical versus a synthesis lab. But when you're talking about different risk perceptions, make sure that you're using the same definitions. So what I consider hazardous, which means you should wear XYZ PPE and then it's hazardous waste. Where a researcher could hear hazardous and think, oh my gosh, I have to use consumables like one-time use. I can't reuse any of the glassware. I have to get rid of everything. I have to send it through the autoclave just in case it has biological materials, make sure you're working with the same definitions.
I think that makes sense. It's amazing how I have seen, even amongst ourselves, even amongst my EHS colleagues and peers, people arguing past each other and being a third party sitting to the side going, to someone else, you do realize they're talking about the same thing, but they're not listening to each other. They don't even realize it, or something like that, right? Yeah, that happens amazingly a lot. Jodi, what else would you like to add to this, please?
I'm sorry if you hear the land care student weed whacking outside my window, but I like to start with, in terms of risk kind of tolerance and risk perception, I like to start with the really simple probability versus severity, right? Like I like to look at, and for both cases, right? For both cases where someone is really risk averse and someone is really risk overly tolerant, I should say, maybe. So if we start with risk averse, the way that I talk them off the ledge is I say, look, here are the controls, like here are the ways that you can protect yourself, and again, I go back to the standard, start off by, if you have the ability and the equipment, working in a fume hood, wearing safety glasses or goggles, wearing gloves, wearing a lab coat, working at small scale whenever possible, looking at the controls that you have and how that reduces the severity maybe of a reaction, or look at, how you can reduce the probability of a reaction by, elimination, substitution, just kind of going down the hierarchy of controls too. And then showing them how to protect themselves, giving them that power to know that they're protected. So that's for kind of risk averse. For people who are a little bit more risk overly tolerant, sometimes I find that these people are people who've worked in the lab for a long time, and they've been, they say, well, it's never happened to me before. I don't really understand why I should be concerned about this. And just giving them examples of when things can go sideways, I guess. And if that were to happen, I start off with worst case scenario, like what would happen if there's this reaction blew up in your face? How would you be protected from that? Or if anything, going back to say, okay, well, if maybe you don't necessarily care about your own safety, what about the safety of the students that work for you, kind of thing. And so just looking at that and kind of making them realize that even though it has never happened to them before, what the probability or the severity would be, the way that they're currently working, and how it would be easy to get them back to, right? Because they always want it to be easy, how we could easily kind of reduce those things, and looking at that, reduce that risk.
Cool. I want to continue along this line for one more question about risk. I think it's great to talk about that, severity, probability, and then you can also add into it exposure, the third variable that often doesn't get included. People are more used to the biaxial matrix, right? Which I think is always a great conversation. And risk tolerances versus risk aversions can vary widely. Where what we think highly of, we often assign it a positive valence, and so we think the risk is lower for that. And then, of course, the opposite is true. So what about talking about those subtleties of differences? We're not monoliths, like I'm saying, when it comes to risk. And then also in particular, what about having the conversation about what might change for them? So here's the example. We had a group that was using white mineral oil, which is a combustible liquid, not a flammable liquid. And they weren't planning on turning up the temperature, but they weren't getting the results that they were expecting. And so they did end up turning up the temperature, but they didn't reassess the risk profile of what that would do. And they were startled when it burst into flame because they took it from the combustible state to the flammable state by jacking up the temp. Now, luckily, someone close by grabbed an extinguisher, put it out, and done, right? But they just had not thought deep enough that, okay, let's turn up the temp. But, their perspective is the research. They're not thinking in terms of how does this alter this risk profile. So, but go in any direction you would like. And I can't remember who I went to first, second, or third last time. So I'm just going to randomly choose Ashley to start.
I don't have a good answer for you. It's a question I constantly have with my colleagues. How do you get researchers to stop and do an informal risk assessment? That's what you're doing when you have to change your process. Often we have incidents where, for example, we had one who had a gel from an electrophoresis experiment and they had to cut out their gels, and they normally use a scalpel. Well, they couldn't find it or it broke, and so they use a razor blade instead, and they cut themselves. How do you get someone to stop and think, okay, yes, it's very similar, but what's different? What else am I exposing myself to? So I I don't have a good answer for you.
That's okay. No, it was a good one. And I did like the wrong tool, obviously. Yeah, and I've run into that as well. Let's see what the others, Chris.
Sure. Yeah, I mean, I don't think there is a, foolproof, comprehensive way to, determine this. There are a few that, though, where I think you can say you can't really go wrong with, doing that kind of quick supplemental risk assessment. So, I would say if you're scaling up your reaction, that should always, trigger a new assessment. The other big one for me would be if you're, going from an open system to a closed system, where you've got potential for pressure buildup. That would be another one that should definitely trigger a new risk assessment.
Yeah, very good. Yeah, and Jodi, please, what else would you like to add?
So unfortunately, here at the University of Minnesota, we've had 4 really large lab accidents that all involve in some way a change in process that caused it. So one was similar to the gel. They used a gel that was combustible, and instead of heating it in an apparatus that was really temperature controlled, they put it on a hot plate and it combusted and they were burned. We had a situation where someone changed their solvent, and it kind of gelled everything up and it made the stirring less efficient. And there was a pocket that superheated and it blew up. We had a situation where someone used the same reagent, but a fresh reagent, a reagent from a new chemical supplier in a fresh bottle versus the one that had been sitting on the shelf for years. And, maybe that reagent was a little bit more active and it caused an explosion. And then we also had another person who was working on a methodology, and they took a starting material that they were looking at testing out, but it had a functional group on the other end that continued to react and it caused an explosion. So we've had quite a few incidents here at the university, and this has become one of my core pieces in training, is just thinking about how minute changes in your process or even your environment. I've had situations where in the winter, people's reactions work great, or in the summer when it's humid in the lab, the moisture in the air could cause an issue too. So changes in the reagents that you're using, the solvents that you're using, the purity of the solvents that you're using, things like that. We always talk about management of change. And even if you think it's really small, I like Ashley's comment about the kind of more informal risk assessment, where you kind of go through and you say, all right, I'm going to use this new substrate in my methodology just to test it out to see if it works, if my reaction works. How should I do that? Okay, let's take it back. Let's do it on small scale first. Let's kind of go back through that scale up. I'm going to change out my solvent. I shouldn't do that on large scale. I should try that on small scale and see if it causes anything to crash out because I've changed that polarity. I kind of know this from my experience in chemical synthesis, but just talking to researchers about, all right, you're changing this. Could changing this cause an issue later on down the line? And how would you, control for that, I guess?
Yeah, no, absolutely. I love the conversation. I feel like I'm learning a lot. I'm not looking to become a CHO, obviously. I want to take us in 1 minute to a little bit about, what's really been the most valuable for you, the analytical, the intuitive side, the communication that you bring, what is it? And maybe we'll merge that with one of the questions in the Q&A, which is, of course, someone's interested in getting the CCHO, the certification as a chemical hygiene officer. So maybe we'll kind of merge that. But first I would add to this, we talk a lot about what ifs and failure mode and all of these other tools. The tool I like to use the most, and I use it for myself as well as with others, is what's called a pre-mortem, right? There's post-mortems, okay, I'm going to do a post-mortem on this dead body, but a pre-mortem is before you have a dead body, what do we think will have caused this? And it's actually used for projects. If this project dies, what killed it? Not if the project doesn't go well, if the project dies, worst case. And so I've found good success with that. And when people struggle to think about it, I said, look, we've got Sherry Sanji, we've got Thea Eakins-Coward, we've got Preston Brown, we've got Karen Wetterhan, and we've got Michelle Dufault. Those are my big five researchers that either died or were severely maimed. The day that that happened, they did not think, oh, today's the day I'm going to die or get my arm blown off. So with that sort of re-perspectiving, that's not a word, folks, but feel free to use it if you'd like. Okay, I don't guarantee a good grade in English. You know, I'd be very curious if that is something that you've found any success with. And I'm going to mute because our dog seems to not like someone walking by. Maybe, Jodi, you could just briefly touch upon that, and then we're going to take a quick break and move over to the Q&A. So maybe a brief response on pre-mortems from each of you. Jodi first.
Yeah, so I think that's a good, unfortunately, I forever go back to kind of looking at preventing an incident that had happened somewhere else, right? So it's always, for me, I struggle to kind of come up with that like pre-mortem without having the post-mortem, you know, somewhere else. But one of the things that we've been starting to do more is focusing on near misses. So we've been asking our researchers to kind of report near misses to us. And one of the ways that we've gotten a lot of success with that is by partnering with researchers so they know that they can rely on us and that we're not just coming in to kind of to use the overly used term to police them, you know, that they know that we're kind of a partner in safety with them and that they can kind of tell us anything, you know, and that they're not going to get in trouble. So one of the ways that I do that is I take some of these near misses where someone says, wow, that could have been a lot worse. And I make sure to distribute it either via our department safety officers. We have department safety officers that represent an entire department, and they send it out to every researcher in their department, or through safety training, or through our website, just to talk about, you know, hey, this thing happened and it doesn't sound like a big deal, but here's how it could be, you know. And so with the near miss and the learning experience reports, we can kind of almost do a pre-mortem where it's like, hey, this person recognizes that this is a really close call for them. So let's make sure that it doesn't happen to someone, you know, for real next time, I guess. Great. I think that's my best answer.
Yeah, I think that's good. Ashley, anything you want to add on pre-mortems or something along those lines? And then I want us to transition to the Q&A here.
I actually keep track of all of our near misses, not just at my site, but globally. And I keep track of all the incidents globally. And so I'd like to do a lot of data analytics because I like data. It's just what I do.
Yeah.
So I can do some predicting and see like what's going on now in the near misses so we can try and prevent it from.
Great. No, I didn't mean to cut you off. That was great, please. Chris, oh, sorry, Ashley. Yeah.
No, that was it. That's all.
No worries. This is always fun. You can tell I'm not about to become the host of the Late Late Show or something like that, so don't worry about it. Chris, wrap this one up for us, and then we're going to launch the poll next. So please go ahead.
You know, we've only kind of started dipping our toes in, you know, in that area, but you know, I have had some success with that. You know, in, you know, having conversations with, you know, you go into a lab and you ask them what their biggest hazards are, and they say, oh, well, we don't do anything hazardous. And I found that, you know, a pre-mortem can be a really effective way to, you know, say, okay, well, you know, tell me, you know, let's say in the next year you're going to have an accident. Tell me the story of that accident. I found that that's been an effective way to get people to kind of think maybe a little bit outside the box, at least for themselves, about what might be hazardous in their environment.
Yeah, and I love, oh no, we don't do anything hazardous, right? And I'm sure that we've heard that a lot. I'm sure I've said that a lot, and people look to me and go, really, John? This looks a little hazardous to me, right? And so it's just one of these cognitive biases, a little bit of confirmation bias, maybe a little cognitive dissonance going on as well, but also this issue of what I like, I don't believe has as much risk. It's just it's how the human brain works. So we often have to help. All right. Well, my co-host here, Matt, is going to launch our poll, and there it is. Matt is always on top of things very, very well. I will miss Matt dearly. And so please, we rely so much upon all of the attendees to help us figure out what topics do you like and what topics do you wish we would do. So please, everyone, vote on this, and please indicate any interest you wish that you have in becoming a panelist. It's really I think fun. Chris has now been a panelist a couple of times, Jodi as well. Ashley now has joined us, and she and I talk about all sorts of stuff, and we may have Jodi back in adult learning topic, just to give a little teaser there. So please do your voting. We're going to transition over from our questions, but I think what I'd like to do is I've scanned some of the Q&A. There's been a lot. There's been a lot about this, about resources, and it looks like resources has been really well answered by the community. Thank you all very, very much. The chat is full of stuff, the Q&A is full of stuff, and that's a lot of why we're here. But there's also a few questions about, how do I become this, or at least how do I grow in this area, right? I took a short course that was chemistry for the non-chemist. And to me, that was the inspiration I had for this. So Jodi, Chris, and Ashley, just a little bit, because we're going to run out of time here pretty darn quick, but your journey to becoming a CHO, maybe other things you did separate from that for professional development, what would you say, what would be your one or two strong recommendations for people who are really looking to grow in this area and maybe become a CHO? And I have no idea who first. I'm just going to go straight across. Chris.
Sure. So in terms of, at least for me, I've found, the most useful things that I've had for professional development have been more on the non-technical side. Taking some of the management and leadership courses that they offer on campus through our HR system have been really useful, both in the team that I'm supervising, my team, and in using some of those techniques when working with the researchers.
Nice. And I love that it was more on the management side and communication and all. Chris, very, very cool. Of course, that's confirmation bias for me. It fits my mental model, right? I'll definitely culp to that. Just because I study it doesn't mean I don't experience it. All right, Jodi, you're again in the middle here.
Yeah.
One or two, and then I'll go to Ashley. So sorry.
No, one of the things that I would say beyond what Chris mentioned about kind of leadership and communication is if you have the opportunity to do some physical training. So, when I say that, I mean, get into a lab. If you want to be a chemical hygiene officer and you want to understand chemical safety, if you have the opportunity to either take a lab class or to do some sort of hands-on practical training, I think that's probably where I draw most of my experience and answers from. It literally falls back to me thinking back to, okay, what did this look like for me? Or what did this feel like for me? What felt right? We talk about that intuition, or how does this work practically? So having that practical knowledge is completely invaluable. And I know that EHS professionals I had, when I was a graduate student, were looking into maybe auditing a lab class or taking one of the organic lab classes or something like that. Working in academic institutions, we oftentimes might have that opportunity. So that's what I would say.
Yeah, super. And Ashley, please.
Just echoing what Jodi said, I personally will ask to work in a lab if I don't understand what they do. We have an insectary on campus. I have no idea what you do in an insectary. So for a few days, they just put me to work. And now when they talk about their processes, I have a better understanding of what they're doing. So definitely get hands-on experience.
Cool. Great. Thank you all very
Communicate
much.
using the same hazards or definition.
Cool. All right. I like this question here. I think it fits in. If we've already explored it, feel free to remind me of it, right? But Casey asks, are there any recurring situations you wish more researchers or scientists would come to you beforehand for consultation and advice, right? It's always I wish you had asked me this before you tried that. So does anything come to mind? And I'll sort of add on Glenda's question, because I think it's really part of this. What's been your biggest challenge here? So feel free to go in either of the directions. I'll go in the reverse order this time. So Ashley, you're up first.
Can I go second? I need to think.
You can, absolutely. Jodi, I'll go to you this time. See, this is great. Yeah. I'm never prepared when I've been a panelist, I don't know how many times, and I'm like, I was reading the Q&A. I'm sorry, Matt, what was the question again?
I would say that I wish that more researchers would come to me when they are looking to do something radically new, or like use a new piece of equipment or use a new technique, because sometimes based on their location, I mean, we have some really old lab buildings on campus here. It's like, it might not be possible for you to use that thing. Why did you purchase it? So I think that I would say, coming to me to talk about their limits or potential limits based on their location. So we could we've wasted years of a person's time trying to find a better room that would suit a piece of equipment that they wanted to use. So I would say maybe that, if they wanted to kind of radically change their research, I would like them to come to me. And then to go into those challenges though, if someone is in a facility that doesn't have the ability to do what they want to do, it's so hard, from my perspective, to try to get them funds to change that. In some cases, it's hard for me to say, I'm sorry that your department put you in a really old building in the basement and you cannot do this type of research there. So coming to me ahead of time and saying, hey, this researcher wants to use this big piece of equipment, should we put them in the basement? No. So that's kind of where the challenges lie, is where your hands kind of get tied, I guess.
Yeah, no, I think that's good. Ashley, you had requested second on this, so I'll go back to you now, of course.
So I guess along the lines that Jodi was saying, before someone starts using a chemical, I really want people to come and talk to me, especially if they've never used it before.
Yeah, especially if it's their first time. Absolutely. And Chris, what else would you like to add to this, please?
Nothing to add to that point, but I think you did also mention something about issues that keep coming up over and over again. And one thing that I would say about that is, if you're working in a university environment, be prepared for that. I mean, the researchers turn over every 3 to 5 years by design, right, as they graduate and move on to bigger and better things. So, you're going to be constantly retraining each new crop as they come in every year.
Absolutely. Yeah. Yeah. And, as you're talking, I'm thinking about the times I interacted with engineering researchers on a couple of the campuses I was on. And whenever I could allow them to, like you've been saying, help me understand their research from their perspective, I was always better off. Sometimes, it was almost a superpower that I didn't understand a lot of the research. And I could say, I just don't understand it. Can you explain it to me? And just, what? I love learning about your research. But in the interest of time, can you just talk about the hazards to focus them, right? And sometimes that was the best thing I could do. So there's a lot of great discussions here that have really, I think, been addressed by the group at large. A lot on SDSs in particular, and when things go in different directions. So maybe we could talk at least a little bit about how do you help them understand implications outside of the things that they may not have anticipated. And so the example here is they want to use a new chemical, and the chemical has environmental requirements to it. So all of a sudden, the concern is, okay, you can do this, yes, but now this affects our permit it affects our discharge, it affects this, it affects that, that maybe people aren't even aware of. So what about in those respects? And Chris?
Yes, I mean, that's just an area where, you know, building those relationships early on when they first come to campus, you know, building those relationships when you first step into, you know, whatever role that you have relative to them is going to be key, right? Making sure that, you know, you're in a position where they see you as a resource. You know, that way they will come to you, you know, before it's too late on those issues. And then, you know, at whatever point they're coming to you, you know, just, you know, walking them through the, you know, I'm not telling you, no, you can't do this. I'm telling you, this is what it's going to take to be able to do this safely or legally, et cetera.
Great. Ashley.
I hardly ever say no to chemists or to researchers. I always tell them, like what Chris was saying, you have to jump through all of these hoops if you want to use this chemical. Do you really want to use this chemical? Often they say no and they change their mind and find something else. But yeah, I just tell them, okay, so I'm not going to tell you how to do your research, just do it safely in this little sandbox.
Nice. And Jodi, please.
I love what both of you said. The other piece that I will kind of remind people of is knowing their resources. So as an EHS professional, knowing your resources. And if someone comes to you and says that they want to use a specific chemical and you see this, the potential for an alternate regulation to apply to it, knowing who you can go to. So I am not an environmental protection person, but I have an amazing colleague who is, and I'll always just run something past them, you know, to kind of understand if there are additional regulations that apply beyond kind of the ones that I know of in my little realm. And so kind of knowing who your peers are, if you have any on, you know, your campus or on sister campuses or within kind of the safety professional organizations that you're in, to help you with that.
Nice. Very, very good. You know, it's amazing how much the community is helping out here as I'm scrolling up and down the Q&A, because it changes based on votes. And it looks enormous. There's 25 things listed, 9 answered, right? So 34. And yet when I look at it, they're all answered by either you or some others in the community, et cetera. So I'm going to actually go to the chat where people have still been posting lots of stuff. So Maria asks an interesting question here. Has it been assessed as to how most staff react under pressure or stress? I love this question already, right? During a real exposure event in typing in chemical names, locate the correct SDS in an online database, or reacting differently. So maybe, since we have had a wonderful discussion on the value of lessons learned and all of that sort of stuff, maybe we could talk about your experiences when something has happened, right? And, you know, what are some of the reactions, not chemical reactions, human reactions that you've seen occurring there? So, look, Jodi, you know, I love this because someone's giving me a sign that like, I think I know what I want to say here, John.
If I could answer this, and it actually gets to another point that someone mentions in the chat. So there was another question in the chat asking me, you know, mentioning near misses. So we have a lot of pushback on doing that because it creates a bad perception. So what I'll say is that, you know, with near misses, we've kind of created a culture of sharing on the campus and sharing both near misses and incidents. And it's kind of expected. And part of the way that we get over that bad perception or the negative perception is that in both sharing of incidents and sharing of near misses is that we kind of sanitize the report, right? We take away the names and the locations and the departments so that it's really just sharing an event that happened. But one of the things that I will say is that during several of the incidents that we've had that I've shared both with the safety community, you know, maybe through SHEMA or wherever, or even within the University of Minnesota itself, the severity of the injuries were either increased or decreased by the way that people reacted. And in the case where the severity of their injury greatly increased, it was a situation where the person was alone and they panicked. And so what I will say is that even during a pandemic, when we talk about social distancing and we talk about the possibility of having people do research in a socially distanced manner or possibly alone, I will say that people do, when an incident happens to them, no matter what size, there's the possibility that they will panic and they will choose the wrong thing, which means that they kind of increase the severity of their injuries. But the two cases where we had people who had socially distanced coworkers who could kind of help them out and calm them down, they called 911 or they got the person to, the eye wash to make sure that they were helped. So I will say that, yes, like people's during an incident, whether it be a spill, we had a situation where a researcher broke a 4-liter bottle of benzene and shut themselves in the room and tried to pipette it off the floor. Yes, not melt pipette, thankfully, but the decision-making is affected by whatever it is, whether it's an injury or a spill or something like that. And so I will say that it is invaluable, first of all, to share lessons learned, to kind of give people that like track of, okay, I learned about this incident and what they did was X, Y, Z, or to have someone nearby who can kind of help them out.
Great. Yeah. And I don't know about the rest of you, but I have experience with benzene and I'm horrified that someone shut the door and tried to pipette it. And I actually, when I grew up in chemistry, which is ages ago, we still did mouth pipetting. So yeah, that would be a relatively, I'm pretty sure, a bad thing to be doing. So yeah, very interesting. Ashley, what about you as your experience as far as how people are reacting and the differences it makes, positive or negative or whatever, go in whatever direction makes sense for you?
So when I was in academia, if there was an accident, chemical spill, exposure, whatever, people reacted more frenzied, but at Corteva, we do drills on chemical spills or chemical exposures. And what do you do here? Who do you call? Where's your chemical spill cleanup kit? So we drill it into people so they know what to do in the event that it were actually to happen.
Great. And Chris, please.
Yeah, I mean, I've seen, some of those reactions go, all over the map as well. Some labs that, respond exactly, the way we would expect them to. Others that, take some prodding to, get them down the right path. Yeah, having someone, who's right there, who's going to be able to keep kind of their head above water on that is definitely going to be very helpful. Yeah.
This is awesome, and I realize that we're actually after the hour, and so of course this is great conversation. We can continue for a little bit here, probably just another 9 minutes or so, if our panelists are willing and able, of course, and we still have 180 people who are digging whatever we're talking about. So I appreciate our panelists and all of our attendees for this. It sounds like there's a lot of interest in this area. And of course, I will admit it's an area that I study and work in. And so I love it as well. Confirmation bias, of course, or just the bias of self-interest, right? So the very short story, and I think this was told in our last webinar on evaluating hazardous chemical reactions. There was a researcher who spilled a base and thought, oh, what should I do? How should I take care of this? The spill kit was within reach. It was not an emergency. They didn't have to do it. And so they decided to conduct basically an experiment on the floor. And they chose nitric acid to clean up this relatively low hazard base. And they only stopped when they realized that it was destroying the floor. So that was an interesting, not a panic situation, but just someone who had that perspective. So I love the discussion, both live and in the chat, about training is all well and good, but you really need to practice this under real but safe situations. And I do think, as a little teaser preview, we will probably come back to this topic on under adult learning, and there may be one of the panelists on right now who will be joining us on that. So stay tuned for that. It might not be for a couple of months here, folks. But anyway, let's talk about this. And how do you really help people prepare for the things that they don't expect, and work through these situations? We've talked about premortems, a little bit on training. It is tremendously difficult. I will just end with this and add, my particular area is that the use of stories are wonderful as a way to help people take context, perspectives, identify with the people in the story, et cetera, et cetera. So go in whatever direction it seems best. There's a lot of room here. We might end up ending on this anyway. And I have no idea where to start. So I'm going to start in the middle. I'll start with Jodi. And so give us 2 minutes tops, Jodi, and we'll go to the others, and we're probably going to wrap it up after this.
So I actually liked what Patrick Ryan said in the comments about kind of training for some of these types of situations. And one of the things that I've found most invaluable is practical training sessions. And it's actually one of the things that researchers request like all the time. And some examples of that I have is we do live fire extinguisher training, and we especially do this for some of our high hazard groups, where we have a barrel and we light it on fire, and they use fire extinguishers to put it out. And now I will say that we have a hazmat who does this, and he is a firefighter. He's actually a firefighter for one of our cities in the area, and he does an amazing job. And there is nothing like fighting a real fire where you can feel the heat and you have a fire extinguisher and you can handle it. And I will also say that multiple people who have taken that training have successfully put out small lab fires. Not that they should have had to, but they did. And they were in the training session, and they didn't panic, and they did exactly what they were told to because they had that experience. Another example is spill scenario. So you have a spill and there is, and you actually like go through and clean it up. The other thing that we did recently is we had a full scale emergency procedure, like an accident. It was kind of like a dramatized accident where emergency personnel, fire, paramedics, police, and the researchers, we had real researchers come in and practice what to do if there was an emergency. So putting people in those high pressure situations where like there's a fire or there are 5, firefighters coming at you in full gear, and getting them to respond is, I feel like, a really good way to do that
Awesome.
Training and to prepare people.
Awesome. And it's really neat that there's a conversation going on in the chat while we're talking about this. I want to make sure I get to both of our others. So Ashley, you can go next. Chris, you're probably going to have the last word on the questions, and I'll do a wrap up here. So Ashley, please go ahead.
I can't stress enough how important hands-on training is. You can't just sit and read a PowerPoint or a document and then you know exactly what to do in a situation. You have to have the experience. For example, like with Jodi was saying, we had a fire in our greenhouses a few months ago, but no one was injured. People knew exactly what to do. The fire department was here for like 5 minutes because we had taken care of it that quickly, because we do fire drills and we know exactly what to do in an event.
Nice, great. And Chris, please.
Yeah, absolutely. Right now, that's one of the things that, we do recommend for labs as, something that they can do as part of their, internal training requirements that we have for them. And we're also, looking right now to try and acquire some space to put in a training lab so that we can do some more of these things. space is always a challenge at a university, but we've got some executive leadership support. So
Awesome.
looking forward to being able to do that in the next few years.
Yeah, I think that's great. I know that was something that my chemical safety specialist and I were really looking into and trying to do. And what we arrived at is that having one space designated was going to be a problem because we were always moving PIs and labs all around. And so instead, if we could outfit a couple of carts with what we needed, and then whatever lab happened to be empty, in transition, we could use that as our usable space, because often you have spaces that are going unused for a period of time. But if you can get a fully designated space, man, that I think that's the best. We're going to wrap it up here, folks. This has been so wonderful. We've still got over 150 people still remaining here. That just really makes us feel wonderful here. Thank you so much to the panelists for generously donating their time, not only today, but in preparation. There is some stuff, obviously, we do to prepare and get our questions in order and all of that. But thank you all, the attendees, so much, not only for coming today, but wow, for really helping each other out and participating. That's the vision we have. That's why we call this the EHS community webinars that Matt really started for us. And we do want to thank Matt so much for everything that he has done for us and really getting this going. It's been wonderful, wonderful here. And so I'm gonna end it with that. There's so much more, but I do think we're gonna come back to the overall topic of how do you do effective training to prepare people for the things that they may not be anticipating. So everyone stay tuned. If you have any ideas or thoughts, you know how to reach me, first name, last name at bioraft.com, jonathan.clain. I will respond in a heartbeat if I get your message about any sort of idea or thoughts or questions you have. So with that, we're going to end. We're going to save and archive the different things here, folks. And thank you all again for coming, and have a wonderful rest of your day. Make sure you're assessing your risks properly, folks. All right, take care, everyone. Thanks again to our panelists. Bye-bye.